Hello, welcome to another online lecture on distributed networks. So, in today's distributed networks lecture, we are going to be looking at scaling VLANs. So, VLANs is a topic that we have covered previously in previous courses, including advanced networking and others. And in this lecture, we are going to extend further from that and think about what are some of the other sort of concerns when we are thinking about VLANs in much larger deployment environments. So that is the context that we are going to approach VLANs today. But to start with, we'll just go back to some of the things that we have discussed about VLANs previously and revise what we have covered so far. So we already know the basic idea of VLANs or why we would want to use VLANs, and that is our ability to segment networks, our ability to separate networks or devices belonging to different networks, not by their physical topology or not by their physical structure, but by our functional requirements. For example, what we can see in this diagram is, say, if there are three different entities or three different flows of a organization. So normally those three flows, which are physical entities, will be connected to different switches, and that is the connectivity that we have. And the sub networks would be based on that physical separation. So one sub network would be that physical separation. So there will be three different physical sub networks based on how we have organized that. But in reality, in many organizations, in many environments, what we may want to do is, within the same physical space, having people belonging to different entities in. So all these people may belong to the same physical entity, logical entity or organizational unit, but they may sit in different places and they may be connected through different switches. So VLANs are there to address that requirement. So how one switch can be used to connect to different computers, for example, that belong to different networks or different subnetworks. So that is the basic idea behind VLANs. So what we get out from using VLANs is the ability to split switches. So we can have a single physical switch, but that single physical switch can now be split into two or more virtual switches. So normally, if there is a switch, all the devices that are connected to that switch will be connected to the single network that it is connected to, the switch is connected to upwards. So if this is a switch and if it is connected to a router, all the devices here will be connected to the same network. But with VLANs, what we are trying to do is, we are going to make some of these devices belong to different networks. So with the same switch itself, we are going to have devices that belong to different networks. So essentially, we are going to split the same physical switch into a number of two or more virtual switches. Then once we split it like that, any traffic that is going to one part of the virtual switch or one part of the virtual LAN is only visible to that virtual part. So any other device in that same virtual LAN can see that, and others are not able to communicate with them. So the inter-VLAN network, so communication between two different VLANs, even if they are connected to the same switch, will have to be done through inter-VLAN routing. So it will have to be done as two different networks, not as how they are connected to the same switch. So if there is no VLAN, anything that is connected to the switch can communicate with each other. If there are VLANs, only devices that belong to the same VLAN attached to the same switch can communicate. Others will have to go through inter-VLAN routing. Then other thing that we can think about when we are thinking about VLANs is how we are assigning VLANs, or how VLANs are assigned to devices. So the main thing to remember is the VLANs are only assigned to the switch ports. So on the switch itself, the port will be assigned to a particular VLAN. So here port 1 is VLAN 1, port 3 is also VLAN 1. The devices or the host devices do not get a VLAN assignment. So the host devices don't get any VLAN assignments, only the ports on the switches get VLAN assignment. Then any device that is connected to that particular switch port will be given the same VLAN assignment. Say for example, if a device is connected to the port 1, that will be given VLAN 1. If it is connected to port 2, it will be given VLAN 2. If it is connected to again port 3, it will be given VLAN 1. So that is the way VLANs will be assigned to host. It will be assigned to ports, and anything connected to that port will get the VLAN. And main thing to remember is VLAN means it is a device belonging to a separate subnet. It is a separate network altogether, even if they are in the same switch device. Then assigning process would be two parts. One is we need to connect a host to the correct port. Say for example, if we need to connect this device to VLAN 1, then we have to go and see a port that is assigned to VLAN 1, and then we have to connect the device to that. So that is the way we assign a device to a port. So we will connect to the correct port there, and then that particular port, or because it belongs to a particular VLAN, the IP address that should be given to that should be given under the particular subnet. So we'll have to consider what is the subnet that we are using there, and we have to give a IP address appropriately. If it is under VLAN 1, we have to consider what are the IP address range belonging to VLAN 1, and then we will give that there. And in terms of communication between devices, again, only the devices that belong to the same VLAN can communicate with each other. Then another thing that you may remember from VLANs is about broadcast domains. So that is, what is the broadcast domain for a particular network? Say for example, if a number of devices are connected to a switch, so then we would consider that as the broadcast domain there. Whereas in the case of VLANs, that broadcast domain will be now split into the specific VLANs that we have. So if we don't use any VLANs, the switch itself would be the broadcast domain. The switch itself would be a separate broadcast domain for each of the switches. But if we are using VLANs, then it would be a single switch, but within the same single switch, it would be possible for us to have a number of different broadcast domains, number of different sub networks, and each of those networks may have different IP address ranges, everything can be different, but they can still be connected to the same switch. So that is the main difference that we would see here. Then another thing that we have discussed previously is about VLAN trunks, or what happens if we want to connect VLANs across multiple switches. So for example, if we have a particular switch here, then we can assign some ports to different VLANs accordingly. According to our need, we may assign certain ports to certain different VLANs. And then for example, if we have another device also, and there also we may have certain different ports and we may assign them to different VLANs. Now if we want to connect them sort of to another switch, then we may have to connect these two switches or these three switches using what is called a VLAN trunk. So a VLAN trunk is a point-to-point connection between two switches or similar devices. So it is going to carry VLAN traffic or information with VLAN information across that link. So that is what we call as VLAN trunk. So they will carry frames with VLAN identifiers, and each of those frames will have what is called the tag identifying the particular VLAN that they belong to. So that is VLAN trunks and how we would use them to connect multiple switches that carry similar or same VLANs. Then one of the things that we previously discussed as well is about how VLANs can be used and how VLANs have certain advantages, but also they have some significant complexities in using them. And those complexities will be even amplified when we think about much larger networks. So for example, many of the complexities would be about administration and maintenance of these devices and network. Say if we don't use VLANs and if there is a switch and that switch is no longer working or we need to upgrade, we can just remove the switch and put in a new switch in that place, connect all the wires, everything will be fine. But if we have VLANs, now all the specific ports are may be assigned to different VLANs. So say if it is a 24 port switch, and 8 of those ports may be in a particular VLAN, another 16 ports may be in a different VLAN, and they may be scattered across the device. So now if you want to replace them, then we need to know what are the VLAN configurations and we have to reconfigure the new switch to match that. Then also if we are connecting multiple switches, again then we will have to connect different those also as specifically as VLAN trunks. So if we are connecting multiple switches, they should be connected as VLAN trunks. And also when we have larger number of networks, particularly spanning across different devices, and if we create so many VLAN trunks across buildings particularly, a lot of these VLAN traffics is going to be carried through this broader network. So unnecessary traffic may be carried forward without compromising the bandwidth usage. So that could also be a problem that we may have, and also that would also have even larger complexities when it comes to maintenance and administration. So that is also something to keep in mind. VLANs have certain advantages as we briefly discussed before, but they also have a lot of complexities when we want to use them. So if somebody asks like why do you want to use VLANs, there would be some good reasons, like we want to separate multiple subnets but you can't have many switches, so we can use a single switch and separate multiple networks. So for example, we may want to use the IP phones in a separate network, building controls in a separate network, Wi-Fi users in a separate network, wired users in a separate network. So likewise we can separate users into separate networks but still using same switches, and we can control traffic, for example the management traffic or who can access the routers and switches and administer those switches. We can separate that type of traffic also. So those can be some good reasons. But just because we can use VLANs or VLANs are pretty interesting things, so we want to use them, those are not so good reasons to using VLANs. So if there is a valid reason to use VLANs, then we would use them. Otherwise it may not be something to use, and they can have significantly negative impacts as well in terms of performance and things like that if we are not using them properly. So next, we will look at VLAN trunking protocols. So with VLANs, there are certain advanced topics or advanced concepts that would be relevant to us when we are thinking about using VLANs in much larger networks. Beyond the basics of VLANs, these are some of the things that would be very helpful to us when we are designing and implementing larger networks. So the idea behind VLAN trunking protocols is about what happens when we have large number of switches and how we are going to inform about different VLANs across these switches. So for example, if we have 2 or 3 switches, we can go into them and change any VLAN specific information much easily. But if we have many hundreds of switches in an organization environment, going and changing any VLAN specific information on each of these devices may not be practical. They may not be ideal in terms of administration point of view. So in that context, what we would use is what is called a VLAN trunking protocol. This is a Cisco proprietary protocol that is available in Cisco switches. But the main idea is the VLAN specific information will be communicated to different switches from a centralized switch. We may elect a switch as a VTP server or VLAN trunking protocol server, and the other devices will be configured as clients, and this information can be propagated from the server to the clients. What we would try to do with VTP is, in an overall sense, we would have certain basic information that we want to communicate to these other switches. So we would first configure a particular switch as the VTP server, and that would be distributing and synchronizing all the VLAN information of all the trunk links to other switches. This would be transmitted or transferred using what is called VTP advertisements. So VTP advertisements is the format of communication that will happen, and there will be what is called VTP modes that will dictate what type of communication can happen between them, and as a protection mechanism or safety mechanism, there can also be a VTP password that will be necessary for these communications to happen. So VTP server is the device that will be advertising the VTP domain, VTP information, and to all the VTP enabled devices, enabled switches. VTP clients are the ones that are going to receive this information from the VTP servers. Then we can also have what is called VTP transparent switches. These switches do not participate in VTP, but they would forward VTP advertisements across them. Say for example, if we have a switch, if we have 3 switches, this can be the server, this can be the client, and this can be the transparent one. So any advertisements being sent will be sent through this server, but it will not be used by this transparent switch. So that is the main difference between them. So there will be servers, clients, and some of them will not be participating in VTP, but they may forward that information across. So this again summarizes the same information, but the main thing to remember is VTP servers are the ones that are going to store the information permanently, whereas VTP clients are only storing the information in the RAMs. They are not going to store that information permanently. So the same thing also applies to transparent switches as well. So when we take a basic VTP operation, there are 3 types of information that would be shared in these in BTP. So first one is what is called summary advertisements. So summary advertisements are what would be sent by the if there is a new VLAN is added, then it will send a summary advertisement that will contain that information. Then if it will also include whenever new summary information is sent, it will also include what is called the configuration revision number. So if a receiving switch doesn't have that last update received, so if last configuration revision number is 35 and this switch has only received 34, it may ask what is called the advertisement request. So the advertisement request is about asking for more information because it doesn't have that last advertisement. So then it will send what is called the subnet advertisement that will contain all the VLAN information. So first a new VLAN is created, then that information is put in what is called a VLAN summary advertisement or BTP summary advertisement, and that will be forwarded to all the switches connected. And if a particular switch that is receiving that checks the configuration revision number and sees that it has not received that configuration number previously, so then it will request to send that an update for that particular revision number, and then it will send those subnet advertisements. So those VLAN details information will be forwarded across. So in a typical Cisco switch, we can go and check what is called issue the show VTP status command, and we can check what are the information relevant to VTP happening in that device. So it will show all the necessary informations about what is the domain name, whether VTP is running or not. So all these information will be summarized in show VTP status command. So it can be used to verify the status of VTP in a particular switch. So then, if we think about configuring VTP in a network environment, there are 5 things, or we can do it as a 5 steps process. So first one is we will have to go and configure a particular switch as the VTP server, and then we will go and configure the other switches as VTP clients. Any other switch that we want to be clients, we want to configure them as VTP clients. So we should note that these would be connected using VLAN trunks. Then what we would have to do is we can go and add all the VLAN information on the VLAN or the VTP server. So any VLAN information we can go and add them on the VTP server. Then after that, finally we can go and check if all those information that were added to the server are now received at the client point. So if we again look at that in a bit more detail, what we should do is, if you want to configure a switch as a VTP server, we would go and issue the VTP mode command and specify it as a server. So VTP mode server would specify that particular switch is now running on VTP mode server. Now that is the VTP server. So then we can verify the status of that to see whether it is a server or not. Then on the server device, on the VTP server, we would also specify the VTP domain name. So that would specify the VTP domain name, and we can also specify the VTP password. So that would identify what is the specific VTP domain we are configuring, or the switches would belong to, and we would specify the password there as well. Then we would go into the VTP clients, and there we would set the mode as VTP mode client. So now we would set them in the client mode, And additionally, we have to again use the same username and password as we used with the VTP server. So if we are configuring there, we will use the same information there in terms of the as we used with the server. Same information will be used in the client as well. So we will set the mode as client, we'll set the domain name and also the password. Then we can go into the VTP server itself and we can start specifying all the different VLANs. So we can go into the VTP server and we can specify the VLAN numbers, VLAN names and all these things, VLAN information. We can go and specify that and we can check whether it is specified properly in the server. Once we have done the configuration on the server, then we can let that information be propagated through VTP protocol across to other switches. And then if we go into the clients, VTP clients, and then we check whether the VLAN information is there now, there we should be able to see the same VLAN information now propagated to the client switches. So we give the information on the servers, it will be automatically translated or communicated to the client. So that is the basic idea behind VTP. Now we will look at extended VLANs and how some of these things would slightly differ when we are using extended VLANs. Again, this is something you would recall from the previous courses where we have discussed about extended VLANs. And one of the main sort of differentiations that we have discussed is about the VLAN numbers that we would use. Say for normal range we would use 1 to 1005 and for extended range we would use 1006 to 4094. So that is sort of way to differentiate between VLAN ranges into normal range and extended range. The main difference here is the normal range VLANs are normally stored in the VLAN.dat file, whereas extended ranges are not stored there. But also in the context of VTP particularly, VTP doesn't learn about extended VLANs. So extended VLAN information will not be communicated through if we are using VTPs. So this is again something that we have discussed in fairly good detail previously. That is, normal range VLANs are normally stored in VLAN.dat files, and we can create these. We can use the VLAN ID to create a VLAN, and we can give a name, VLAN name to associate a name to that particular VLAN. And if you want to create multiple VLANs, for example, just using the VLAN IDs, we can even create them using either comma separated or even as a hyphenated ranges. Then after doing that, we would we have to assign ports, different ports to the different VLANs. So one of the main things that we said is, like, say, the hosts are not particularly assigned to VLANs, only the ports are assigned to VLAN. So once we create a VLAN, then we will have to assign specific ports onto which the particular devices will be connected to that belong to a particular VLAN. So then we'll have to go into a particular interface. So we will have to go into a particular interface, and there we will have to specify the switch mode access, and we have to specify the particular VLAN ID there. So that is to specify a particular port for a particular VLAN for a particular port. Then again, this is something that you could recall from the previous courses, some of the commands that we can use to verify information, our configurations about VLANs and what VLANs are associated to what interfaces and so on. And in terms of configuring extended VLANs, one of the main differences that we will have to make is about VTPs will not be communicating extended VLANs. So if you want to configure extended VLANs, then we will have to specify those into VTP transparent mode. So as we said, VTP transparent is when VTP is not active in a particular device, but it can communicate across as an intermediary. So if you want to do that, if you want to create a VLAN in the extended range, then we will have to first make the VTP mode transparent. Then we will be able to create a extended VLAN there. Then another protocol that would be relevant to VLANs when we are thinking about expanding scaling networks is about the dynamic trunking protocol. So with dynamic trunking protocol, this is again a Cisco proprietary protocol that would be available in Cisco switches, Cisco devices, and this is mainly used for the purposes of trunk negotiation. So when we say two switches are connected and the connectivity between them need to be a trunk, or what is the nature of the connectivity between them, that is the dynamic trunking protocol will do. It will do automatic trunk negotiation, which is a protocol for trunk negotiation to communicate what is the mode of communication between those two switches. So in each switch we can go, in each interface we can go and specify what is the switch port mode. For example, we can use switch port mode trunk or switch port mode no negotiate, and then those, based on that, they may function in different manner. So for example, what we can see here is here what we do is in switch 1 we are specifying F01 as mode trunk, and that is connected to switch 2, and there also we are specifying that as switch port mode trunk. So here both of these are set as switch port mode trunk. So then that would mean this particular link will become a trunk. So that link is a trunk because we have used switch port mode trunk on both interfaces. Whereas on the other hand, say if we take F03, that is set as dynamic auto, and on the other switch also it is set as dynamic auto, and in that case it will not be taken up as a trunk. So that is the main purpose of, or that is how DTP would work. So based on the configurations of different parts of the switches or different ends of the links, or how different switches are connected, then DTP would dictate what links are trunks and what are not. So these are some of the trunking modes that are supported by DTP, or so we can, these are some of the options that we can set. So we can set access, dynamic auto, dynamic desirable, trunk, and no negotiate modes. So if we do switch port access, then the interface becomes a non-trunk interface. So it is an access port. So if we have a switch and if we set it as an access mode, then that port is not used to connect to another switch, that is normally used to connect to a host. So you cannot connect to another switch, you can only connect that to a device, a host device. We can connect dynamic auto, then if we connect it to dynamic auto, then that link would become trunk if the neighboring interface is set to trunk or desirable mode. Then desirable is about, again, the the link would become trunk if the neighboring interface is set to trunk, desirable, or dynamic auto modes. If it is trunk, if both are trunk, even if the neighboring interface is not a trunk, the interface would become a trunk. Then no negotiate is about not using DTP. If we set no negotiate, then they are not going to engage in DTP. They are not going to generate any DTP frames. So that is some of the modes and how both ends can. So as you can see in this table, depending on the modes that we associate with each of the interfaces, we may achieve different types of links. So here we can say if you want to verify the status of DTP, again we can use this show command to see what is the nature of configuration there. So whether it is a trunk or whatnot, we can verify like that. Then we can also use the show interfaces switch port command and also the show running config command to see what is the, again we can see what is the access mode and what is the and so on. We can again verify that information using these show commands. Now let's briefly look at some of the things that may happen, particularly when we are configuring multi VLANs, and some of the issues that some of the common issues that we may encounter when we are doing that. One of the major concerns would be about deleting VLANs. So again, the problem is if VLAN information is propagating through a VTP server. Say, if we delete a VLAN from a switch that is in the VTP server mode, then it would remove those VLANs across all the switches. So if a particular switch is the VTP server, and if we remove a VLAN from that, it will also remove that VLAN from all the other switches that are in the client mode. There are some VLANs that we cannot delete, like the default VLANs, and like say some of the VLANs we may not delete, but other ones we can delete using the no VLAN and the VLAN ID command to delete a VLAN. But what we need to consider is any ports that is assigned to a particular VLAN would become inactive when we delete a VLAN. So if we delete it on the server, VTP server, even the ports that are assigned to that VLAN on the VTP client would also become inactive, and until we assign them to a new VLAN. So that is something that we will have to consider. So if we have two switches, we have one as the server, one as the client, both have the same VLAN information, and if we delete a specific VLAN here, say VLAN 20 is deleted from the server, VLAN 20 will also be deleted from the client, and any ports that is assigned to VLAN 20 will become inactive, and then we will have to again go into that particular device, particular switch, and configure that particular port into another VLAN to make it become active. Other concerns that we may encounter when we are using VLANs is about how we are configuring switch ports. So particularly say if you are using the legacy routing model, so this is something you may remember from inter-VLAN routing, the legacy routing model. So where we would use separate connectivities to the router for each of the VLAN networks. So in such a network, we have to configure both the connections to the router also by the same VLAN. Say we have to configure this and this as the same VLAN for it to connect. So here, for example, here this is VLAN 10, but here we have left it as default VLAN. so it will not be used for routing purposes. So that is a problem here. So we have to associate the connectivity to the router interfaces also to the correct VLAN network. So that could be one issue when we are using legacy routing model in inter-VLAN routing. Say for example, if we are using the router on a stick routing model in inter-VLAN routing, again here we will have to configure this particular interface or particular link as a VLAN trunk, because now it is going to carry traffic not just for one VLAN but two VLANs. VLAN 10 and VLAN 30 are going to be carried through this link. So then it will have to be configured as a trunk port, not using a default VLAN. So using the default VLAN there would be a problem. So it will have to be configured as a trunk there. Then another issue that we may encounter is particularly when we are again using inter-VLAN routing, we may configure them to the wrong ports, for example. So we may configure them to the wrong interfaces or wrong ports. Say we have, say here F09, we have configured that as the default VLAN. So configuring the ports, interfaces are configured incorrectly. So that could be an issue as well. Then with router on a stick configurations, a common problem is about the VLAN IDs that are assigned to the sub interfaces. So we can again go into the interfaces and see the configuration about what is the specific VLAN ID that is being assigned to that particular sub interface. So again, we need to assign those sub interfaces appropriately to fix that problem. Then one of the other sort of sometimes it can be seen as a silly problem, but that can happen a lot, is about IP addresses and subnet masks that are being assigned to hosts. Because what happens is, even though both of these devices are attached to the same switch, they belong to two separate VLANs. Then that also means they belong to two separate networks, and the particular IP addresses that we assign to that particular computer should belong to that particular network within that sub-network. So we have to assign IP addresses appropriately to match the sub-network we are using. So this could be a common problem, particularly when IP addresses are assigned manually to host devices and where they may be picking up or they may be using wrong IP addresses or subnet mask. Again, that may impede them from having proper communication or connectivity. This can be verified by you going into whatever the computer and using either IP config or so on, and to see what is the configuration and what are the IP configurations and how they are assigned and so on. So they can be verified using these commands. Then last topic that we want to discuss in today's lecture is about layer 3 switching and how VLANs would be relevant in the context of layer 3 switching. So with when we think about multi-layer switches or switches that can do switching at multiple layers, we are particularly thinking about layer 3 switching. So things that can do routing as part of switches that can do some functionalities of routing. So these are the devices that we would consider as layer 3 switching devices. And there are two different approaches that we may think about. One is called routed ports, and layer 3 routing can happen, and the other one is about switch virtual interfaces, and these are where we would do inter VLAN routing. So that is the main one that we will be concerned when we are thinking about VLANs. So when we think about switching and routing, one of the reasons why in many sort of earlier devices switching was happening up until the very higher end and routing was happening at the very highest end is because many switches were not capable of doing routing at higher speed. So that was the reason. But these days we have devices, the switches that we have can do routing functionalities at higher speeds or higher speed of the communication speed. So these devices can themselves be used to do a layer 3 configured as layer 3 gateways so that they can do some form of routing. So either using switch virtual interfaces or SVIs or using routed ports. So we may use SVIs particularly as it is used as a virtual interface that is configured in a multi-layer switch. So that particular virtual interface, we will configure that in a switch, and that virtual interface would be functioning as a gateway, functioning as a way to route between two different VLANs. So anything that is belonging to VLAN 20 can be forwarded to this particular virtual interface. 10 can be forwarded to this virtual interface. So that is the main idea behind using SVIs for inter VLAN routing. So the main advantages of using SVI is that they can be much faster than router on a stick, and we don't need any external links going from the switches to the router. So instead of switches connecting to the router, we can have the routing happening at the switch level itself. And also we can combine multiple links to interconnect between the switches, and then we can say, for example, we can do some form of link aggregation like ether channels to combine them and get more bandwidth out of it as well. But the basic idea is, instead of routing happening or any inter VLAN routing going up to the router and coming back, we do the routing at the switch itself and forward the traffic to a SVI or virtual interface. With routed ports, what we have is physical ports. In SVI, we had virtual interfaces. With routed ports, we have physical ports that would act as an interface on a router. So again, this can be used for routing that is happening at the switch level. So particularly routed ports are normally configured between switches in core and distribution layers in the hierarchical model. Then when we think about configuring layer 3 switches with layer 3 configurations, there are a few things that we have to think about. One is, are the VLANs configured correctly? So for each of these ports that are connecting to different hosts, have we assigned the correct VLAN there? So that is the first one. Then if you want to do some form of layer 3 switching there, then have we configured, so say if this is the layer 3 switch, so then have we configured SVIs properly, and have we configured the necessary routing properly? Then at last, any hosts that are connecting to the overall network, again they should be connected with the correct IP addresses, subnet mask and gateway. So all these things will have to be configured if you want to make sure everything works properly in a layer 3 switched environment. So here it's again a simple example to understand this. If you want to create VLANs across a larger building environment, let's assume. So if we are creating a new VLAN on the 5th floor building, so we are adding a new element on the 5th floor building, new network or new set of devices on the 5th floor building to a particular VLAN. So then we would create that VLAN on that particular switch there, but also we would create the same VLAN on the distribution switches to which this particular 5th floor switch is connecting to. So we will create those VLANs on both of those switches or all the sets of switches. And on that particular switch, we will associate certain ports to the particular VLAN, and any connectivity between the distribution switches, we will make them as the VLAN trunks. Then we can also create SVI interfaces on the distribution switches to do any inter-VLAN routing, and finally we can check if the connectivity is done properly. So we can use all the previously discussed commands and things to check those things. So as a summary, in today what we looked at is how VLANs, sort of recapping VLANs that we have covered previously in the previous courses. Then talking about how VLAN trunking protocols and dynamic trunking protocols can be used when we are thinking about expanding VLANs into larger number of switches, so manual configurations of VLANs will not be necessary. Those information can be propagated using these protocols, and also how extended VLANs and layer 3 switching can also be relevant when we are thinking about using VLANs and inter-VLAN routing and so on, how those things may be impacted. So again, as always, there will be number of practical activities for you all to do as class activities that you can submit through LMS. And if you have any questions, you can always contact me and we will try to have a discussion about anything that needs to be clarified. Other than that, until next time, thank you for joining in today's lesson. See you. Bye.